In today's extremely fast-paced and demanding world of business, the management and protection of mission-critical data has never been more important. We spend millions of dollars and hundreds of hours in the selection of this mission-critical equipment. Surprisingly, with regard to the purchase of single-phase UPS, we spend the least amount of time and money on the very devices that supply the lifeblood to this equipment. Stable, clean, reliable, available source voltage. In the next few minutes, we're going to demonstrate a dramatic difference in UPS output and their ability to deliver rock-solid, stable, clean, reliable, available voltage. Let's describe our equipment. We have two conventional single-phase UPSs, both of the same power, both 1 kVA, 700 watts. On this side, we have a current line interactive model of UPS. It represents the most advanced power design available on the market today. On this side, we have the SANYO DENKI America Sanups model A11H, also known as Sanups A. This is a true online double conversion UPS. Today we're going to challenge both of these UPSs with 4 common power conditions: voltage drift, voltage spike, voltage sag, and voltage collapse. We are supplying both of these UPSs with a variable transformer to simulate adjustable utility source voltage as indicated by this meter. The output of this variable transformer is connected to both UPSs. Both of these units are seeing identical voltage throughout this demonstration. Let's see how our line interactive unit performs. Once again, we have this meter indicating our utility input voltage. This meter is indicating the line interactive output voltage that your precision equipment is seeing. Let's go into a drift. One of the most common characteristics of line interactive UPS is the one-to-one relationship of utility voltage or input voltage to output voltage. In this drift demonstration, as input voltage changes, so does your output. Let's proceed up to a spike. As we climb, you're going to hear a click. What just happened is an automatic voltage regulator has kicked in. It's the best this unit can do to maintain output power quality. So here we are at 140 volts. Our output is at 124 volts. Let's continue on down. Back to normal voltage. Please notice the output of the line interactive unit throughout this, down into our sag. As we sag down, again, you're hearing the click of the AVR. We'll drift a bit. That AVR is doing its best to maintain power quality. Watch the variation in voltage. Now our utility decides to collapse. As we get down to 90s, we'll proceed down to 80s. Sit on 80 volts here. Now we're in a full battery event. Your batteries have kicked in and your power is restored. But this unit is leading to one of the highest operating costs of line interactive UPS, the battery purchase. People buy pallets of batteries in protecting the UPS from this very event. You can't see it, you can't hear it, because it's typically stuffed in a closet. But the fact is that battery replacement today represents the highest cost of operating drawback of the line interactive UPS. Let's see how our true online double conversion unit performs. Once again, this is your utility input voltage, and this is the precision voltage that your equipment is seeing. One of the primary characteristics of the true online double conversion is that as input voltage changes, output voltage doesn't, as demonstrated in the drift. No change in output voltage. Let's continue to the spike. Now our voltage climbs back to the 140 level, past the 140 level. Now, our line interactive unit is now in a full battery mode, But our true online double conversion, there's been no change in the output voltage, maybe 1/10 of a volt, and we are still online. Let's proceed to the sag. Let's come back down to normal voltage, and let's proceed down. We sag and drift. Again, notice the output stability. Drifting, now our utility decides to collapse. Down past 90, past 80. Here we are at 55 volts. This unit is rated from 55 to 150 volts and 40 hertz to 120 hertz of true online precision voltage output. For all the engineers out there, we have captured this demonstration graphically on a fluke analyzer. This chart represents voltage stability over the course of time. Your equipment deserves it, your equipment demands it. Consider SANYO DENKI America, Sanups model A11H, offering the lowest cost of operation and the highest level of output power quality voltage available on the market today.